We'll start with now Gibbs free energy and spontaneity of a reaction. Gibbs free energy is that amount of energy that is available to do work. So if this available energy can be released for any process by the system to move on its own to completion, we say that the reaction is spontaneous or the system is undergoing some spontaneous change. The products in such a process, if it is a chemical reaction, will have less energy than the reactants. Spontaneous processes can take place at low temperature as well as at high temperature. Examples, here you see ice subliming. If you keep a chunk of ice, you will find vapor surrounding that ice very soon. Here, ice is going on into the vapor phase from the solid phase. So it is sublimation. Look at the next two pictures. We can see ice stalactites being formed in a cave due to the low temperature. This is a spontaneous process in which ice is forming these hanging icicles. Now here, ice stalagmites being formed on the lake. So again, these are spontaneous processes that take place in nature. These are all occurring at low temperature. So we don't necessarily need high temperature for any spontaneous process to occur. But occurring does take place of these spontaneous processes at high temperature. For example, if you take camphor and if you just ignite it, you will find that it quickly sublimes and there is no change of camphor into the liquid state. So we say sublimation can take place at high temperature as well as at low temperature. Now we talked so much about Gibbs free energy. We saw the relationship between enthalpy of a reaction as well as the entropy of the reaction. How then is delta G is related to the spontaneity of the reactions? We saw last time that sublimation is a spontaneous reaction taking place in nature. Let us see, relating it mathematically, how we can get the spontaneity from the value of delta G. It is important to note the value of T, that is the temperature at which the reaction takes place. If delta H is negative and minus T delta S is positive. Look at this reaction. Delta H is negative, minus T delta S is positive, then negative and positive. At low temperatures, the reaction will be spontaneous. If T is high and the process is exothermic, then careful observation of the entropy term is needed. Is entropy negative or is entropy positive? Is the reaction leading to more disorder or not? If entropy increases, then alone the change in Gibbs energy is negative and the reaction is spontaneous. At equilibrium, the free energy change is considered as 0. So, if delta G is equal to 0, then the Gibbs free energy equation reduces to change in Gibbs free energy delta G is equal to delta H minus T delta S, and that is equal to 0. So that delta H is equal to T delta S. The value of T is always in Kelvin and it is calculated in Kelvin alone. Summarizing, we get the results in the form of a table. If you have delta H positive, that is an endothermic reaction, delta S negative, decrease in entropy, then minus T delta S is positive because minus T into minus delta S gives you a positive term. Delta G turns out to be positive and therefore the reaction or the process is non-spontaneous. If on the other hand delta H is negative, that is the reaction is exothermic, then delta S is also positive. There is increase in the disorder of the system. Then minus T delta S is negative and we have delta G as negative. The reaction is said to be spontaneous or the process is said to be spontaneous. Again, when delta H is negative, that is the change in enthalpy of the reaction or the process is negative, then it is an exothermic reaction. Delta S is negative, that means there is a decrease in the entropy. So minus delta S into T becomes positive. So minus into minus, you have here the whole term changes into positive. Now delta G will be plus or minus depending on whether it is a low temperature, that is T is having a smaller value, or if T is having a very high value. If it is low temperature, the reaction is spontaneous. If it is high temperature, the reaction is non-spontaneous. Again, let delta H be positive now, that is an endothermic reaction. Delta S is going to be positive. There is going to be an increase in entropy and minus T delta S is now going to remain at negative value. So delta G can be plus or minus depending on whether it is a low temperature when we will have non-spontaneous reaction, and high temperature will give me a spontaneous reaction. So the importance of Gibbs free energy stands out like this: to understand the spontaneity of the process or any reaction, to understand the numerical value of the equilibrium constant K, and to predict the direction of the reaction. When the system is at equilibrium, the change in Gibbs free energy is zero. The relationship between the equilibrium constant and the change in the free energy is then written as delta G0 is equal to minus RT ln K, where R has the same standard meaning, that is a molar gas constant. Here, when it is in equilibrium condition, we consider Gibbs free energy change as a standard Gibbs free energy change. Now, T is the absolute temperature. Note, here the free energy change is the standard free energy change, as I told you, and therefore it is denoted by delta G0. If the value of R is taken as 8.314 joules per Kelvin per mole, the units of standard free energy changes, and that is, it becomes joules per mole.